hypothesis. We can have also the hypothesis that the nominal money stock is equal to M0 before T1, and then the nominal money stock start to increase according to a rate of growth equal to me, starting from T1. But we are in T0, which is lower than T1. So there is an expected increase in the rate of growth of the exchange rate. The previous case was a sudden increase in the rate of growth of the exchange rate, just to complicate again the model. Because do you like this model or not? You like this model? So write the solution for the integral to solve this hypothesis. This is exchange rate equal to 1 over alpha 2, which multiplies the integral between t and t1. Between t and t1, the nominal money stock is equal to m0, which multiplies the discount factor e to the power of minus v minus t divided by alpha 2 in dv. And this is the first part. Starting from T1, you have the second part. So you have 1 over alpha 2 integral between T1 and plus infinite. Starting from T1, the nominal money stock start to grow at a level equal to at a rate equal to me. So you have m0 plus me v e to the power of minus v minus t over alpha 2 in dv. Okay, so in this case, the first part of the integral is m0 divided by alpha 2 e to the power of t over alpha 2, which is outside the integral, which multiplies the integral between t and t1 e to the power of minus v over alpha 2 in dv. This is the first part. Then we can split the second part, and we have plus m0 over alpha 2. So we multiply this parenthesis by the discount factor, okay? So m0 divided by alpha 2 e to the power of t over alpha 2 integral between t1 and plus infinite e to the power of minus v over alpha 2 in dv. The first part. Then we have the part with me v, and we get plus me over alpha 2 e to the power of t over alpha 2 integral between t1 and plus infinite of v e to the power of minus v over alpha 2 in dv. Okay, so the exchange rate is equal to m0 over alpha 2 e to the power of t over alpha 2. The first integral is e to the power is minus alpha 2, we know, which multiplies e to the power of minus v over alpha 2 between t and t1. This is the first integral. To alpha 2, okay. The second is plus m0 over alpha 2 e to the power of t over alpha 2, which multiplies, the integral is the same, is minus alpha 2 e to the power of minus v over alpha 2 between t1 and plus infinite. And this is the second integral. Do you agree? Integral, which we need to solve, okay, which is plus me over alpha 2 e to the power of t over alpha 2, which multiplies the integral between t1 and plus infinite of v e to the power of minus v over alpha 2 in dv. And the problem is to solve this integral. Solving this integral, we get the dynamics of the exchange rate. But we can simplify the first two integrals, okay? We can compute the first two integrals, which should be equal to m0 over alpha 2 e to the power of t over alpha 2. The value in t1 is minus alpha 2 e to the power of minus t1 over alpha 2, okay? Minus becomes plus the value in t, which is alpha 2 e to the power of minus t over alpha 2. And this is the first part. I've just computed the value in t1 and the value minus the value in t. The same to the second integral. The second integral becomes, okay, m0 over alpha 2 e to the power of t over alpha 2. The value, if v goes to plus infinity, is 0. Minus minus plus, the value in t1 becomes alpha 2 e to the power of minus t1 over alpha 2. And this is the value of the second integral. Then we have the third part, okay? Plus me over alpha 2, what we need to compute this part, okay? Okay, so we get multiplying by the square brackets, okay, exchange rate equal to m0 over alpha 2 multiplying the exponential, alpha 2 and alpha 2 simplifies, can you see? And we get m0, alpha 2 simplifies with a negative sign, minus m0 e to the power of t minus t1 over alpha 2 plus m0, which multiplies alpha 2 and alpha 2 simplifies, which multiplies e to the power of 0. Try to check this computation. So this is the second integral, which simplify with the first. It remains just m0 plus the what we need to consider now, me over alpha 2 e to the power of t over alpha 2 integra between t1 and plus infinite v e minus v over alpha 2 in dv. Well defined. We are here now as t equal to m0 plus me over alpha 2 e to the power of t over alpha 2 integral between t1 and plus infinite v e to the power of minus v over alpha 2 in dv. This is where the last computation, because the first part simplifies. In order to solve this integral, we can consider the derivative of v, which multiplies e to the power of minus v over alpha 2 respect to v. We know this derivative is equal to the derivative of the first, which multiplies the second, plus the first, which multiplies the derivative of the second. So it's equal to e to the power of minus v over alpha 2, which is the derivative of the first. The derivative of v respect to v is 1, which multiplies the second, e to the power of minus v over alpha 2, plus v, which multiplies the derivative of the second function, which is, what is this derivative? We know e to the power of minus v over alpha 2, which multiplies minus 1 over alpha 2, minus 1 over alpha 2, which is the derivative of the exponent respect to v. We can integrate both sides of this equation. Integral in dv between t1 and plus infinite, because this is the integral we need to solve. It's between t1 and plus infinite. Okay? So the first part simplifies in such a way and becomes v e to the power of minus v over alpha 2 between t1 and plus infinite. This is the first part. The second integral we know is minus alpha 2 e to the power of minus v over alpha 2 between t1 and plus infinite. Then we have minus 1 over alpha 2, which multiplies the integral we are looking for, which is the integral between t1 and plus infinite, v e to the power of minus v over alpha 2 in dv. Try to check also this. From this equation, we get that the value of the integral between t1 and plus infinite of v e to the power of minus v over alpha 2 in dv, okay, this integral is equal to, we need to multiply both sides by minus alpha 2 as yesterday, okay? So we get minus alpha 2 which multiplies v e to the power of minus v over alpha 2 between t1 and plus infinite, which is this. Minus alpha 2, which multiplies, we need to put on the other side, so we get alpha 2 e to the power of minus v over alpha 2 between t1 and plus infinite. Maybe I can write with a larger size, okay? So the integral is equal to, the integral we are looking for is equal to minus alpha 2, which multiplies v e to the power of minus v over alpha 2 between t1 and plus infinite, minus alpha 2, if you want, alpha 2 squared, which multiplies e to the power of minus v over alpha 2 between t1 and plus infinite. This is the integral we are looking for. Try to compute this value. First one should be minus alpha 2, which multiplies 0, because as v goes to infinite, v is lower than the exponential, okay? Is slower than the exponential, minus t1 e to the power of minus t1 over alpha 2. Okay, this is the first part. Oh, anyway, sorry. Okay, this is the first. The second, minus alpha 2 squared. You get 0 as v goes to plus infinite, minus e to the power of minus t1 over alpha 2. So the final value of the integral will be equal to alpha 2 t1 e to the power of minus t1 over alpha 2 plus alpha 2 squared e to the power of minus t1 over alpha 2. You get this result? Okay. So I write what we are looking for was the exchange rate equal to m0 plus me over alpha 2 e to the power of t over alpha 2, which multiplies the integral between t1 and plus infinite v e to the power of minus v over alpha 2 in dv. From here we can substitute the integral we just found, and we get exchange rate equal to m0 plus me over alpha 2 which multiplies e to the power of t over alpha 2, which multiplies alpha 2 t1 e to the power of minus t1 over alpha 2 plus alpha 2 squared e to the power of minus t1 over alpha 2. We can simplify alpha 2. We can simplify alpha 2. and we can collect something, the exponential. The final result is the exchange rate equal to M0 plus me, which multiplies T1 plus alpha 2 e to the power of minus T1 minus T over alpha 2. This is the final dynamics in the exchange rate, and you can check that this is correct.